Hello and welcome to the second day of Breakpoint 2021. This is Jay Dave, your host for Stage 2. Super excited for what we have in store for you today on the second and last day of Breakpoint. We have 7 sessions remaining. Right up next, here on Stage 2, we have Noemí from Amazon, who will kick it off with best practices on managing your test cases, including how you can use AI. In parallel, we have Marit on Stage 1. She'll be talking about how she uses manual testing and automation in conjunction to explore and learn about applications, what she calls contemporary exploratory testing. We'll kick off the next 2 sessions, again on Stage 1 and Stage 2. Next, we'll have an expert Selenium panel. It should be an exciting session. This will be on Stage 1, and there won't be any parallel sessions, after which we'll have 2 parallel sessions on Stage 1 and Stage 2, and then we'll kick it off, and then we'll end the day with a session on Stage 1. Before we get right into the session with Noemí, few housekeeping items. On the left panel of the Hopping UI, you'll see 3 options: Reception, Stages, and Expo. Reception is where you'll find all the general information you need, which talks are live right now, key announcements, and the full schedule for you to explore and add to your calendar. Second option is Stages. Use it to enter live talks and switch between stages. And we'll be doing this about twice today, so you can use that option to switch between stages. The third option is the Expo. We have set up virtual booths where you can talk to solution experts from BrowserStack about your testing needs and challenges. Come say hi and enter for a chance to win Breakpoint swag. On the right side of the UI, you'll see Event and Stage. Make sure you're using the Stage tab for all your interactions. The chat option can be used to have discussions and also to put in all your questions into the chat. I'll be going through these throughout the talk, and at the end, we'll have 10 to 15 minutes for Q&A. The next option is the poll option. I'll be announcing polls after talks. Please participate using this option. Noemí will be starting our talk with a poll as well, so please participate. And the third option that you should keep in mind under Event is called People. This allows you to find fellow attendees and network with them. You can send messages, set up meetings. We highly encourage you to use the chat, introduce yourself, ask great questions, and virtually meet your fellow attendees. Lastly, we are recording all sessions of Breakpoint, and we'll be publishing them in about a week. With that out of the way, I am excited to introduce you to our speaker, Noemí Ferrera, software dev engineer at Amazon with 10 years of experience in development and testing. Noemí wrote her first program when she was 8 or 9 years old. She started as a developer, but got more and more involved with testing and automation of tools and processes over time. Currently, Noemí is writing a book covering a group of side projects that she's been working on throughout her career. Well, with that out of the way, over to you, Noemí.
Hello, everyone. I'm super excited to be here. I'm really worried to be at the same time I'm married because she's super cool as well. And I've done presentations with her before, and I really enjoyed it. So it's super good opportunity to be able to get the recorders afterwards. So I'm super happy that you guys are here. And I see you're coming from all over the world. I'm seeing in the chat that there's people from Mumbai, from Quebec, from Austin, Tucson, from the Philippines, from Spain, Berlin, Chennai. Oh, it's Ohio as well. So hi to everyone. And let me just get started with the slides. If that's okay with you, I will stop seeing myself. So if I do anything, oh, Greece, awesome. So if I do anything weird, don't blame me. I don't see my face anymore. So as I was introduced, my name is Noemí Ferrera, and in here you can see my Twitter account and my website, which also has a blog inside. I'm not writing very frequently in the blog, but that's because of a good reason. As they say, I'm writing a book. So now I'm spending a lot of energy on that, but I'm not abandoning the blog or anything like that. I will going back soon to it. And there was some misunderstanding about this session. At some point, someone mentioned that I was going to talk about VR. I'm not for this session. It's going to be more about AI. If you know AI, it may be a bit easy for you, but still, I hope it's interesting to see what drives me to write this series of projects, right? So I hope you enjoy it. I'm really excited to be here. I'm definitely going to enjoy it. And let's get started. So if you're interested in the VR side, we can chat on the chat after the presentation, and hopefully it will be also in the book somewhere there, so you can get more information there. And so there's a poll, as they told at the very beginning as well, in the right-hand side where the stage is. So next to the chat, you will see polls there, and you can answer that poll. So it's about how many test cases you have to run per deployment. And if you run less than 10, I don't believe you, but still, if you do, just pick the 10 one. And if you have different projects, just pick whichever project is bigger in your mind and just go ahead with that one. It's just to get an understanding of how many people found the same problem that I was on when I started thinking about this issue. So the problem is that I had a really, really long list of test cases that I have to run and execute in order to get my sign off of the new features that were coming. I was new in the team. The person that was there before me left. There was no information about these test cases, and I needed to give a sign off. And some of these test cases were failing, some of them were passing. So how I was supposed to get the right sign off, right? So I can focus on the last feature, but I wouldn't know if anything failed on regression. So I start thinking, how can I make it so I just run the most valuable test cases, or which ones of these ones I can totally ignore because maybe they're old, right? And maybe they're not being used anymore, or maybe they're not needed anymore. So there is this common thing on testing, that we need to be able to decide which test cases are more important, to write them, to maintain them, to remove the ones that are not, and to execute them. And this is what started me into the project that I'm talking about today. So I wonder, I know I can't read the chat right now, but even so, I wonder if you ever found yourself in this struggle as well. If not, what would you do, and what did you do? And even though I can't read the chat right now, I will read afterwards. So the good thing that we have to do in order to figure out the test cases is all about balance, right? We have to be able to have a balance between the quality of the application that we're deploying and the quality of the time of that application. As the deployments are getting faster and faster, we need to be able to decide on the test cases. We need to be able to write the automation faster and faster. So we need new techniques in order to do all of this, right? I could have gone and checked the priority of the test cases, but sometimes people give really high priority to a test case, and then that priority changes because feature changes and no one goes back and change it again. Maybe you can clear the obsolete test cases, but that takes very long time. I didn't have enough time to do all of that. And maybe for date of creation, I can look into that as well. In my case, asking others was not possible, and I could start everything from zero and ignore what I had there before, but there could be something useful there before. So this is the problem that I started. So how would you decide between the test cases? So I'm going to give you some strategies, and I'm going to give you the ideas that I did and some code as well that I write in order to get this done. So when you're doing any automation, the first thing that you need to do is understand the process. So, right, I wanted to automate this process. I wanted to automate this decision. I didn't want to go and, be reading every single one of the attributes of the test cases before I decided which ones to execute. So I wanted to automate it. If you want to automate something, first of all, how do you do it manually, right? So what are you basing those decisions on? So are you basing it on priority, on the novelty of the test cases? Which are the variables that you use, and which weights do you put to that variables, right? How important is priority versus risk of a test cases? So I'm also interested, again, feel free to drop them in the chat. What sort of variables do you use in order to decide among test cases? What would you look into, right? So I'm pretty sure if we have 1,000 people, they will have very different opinions. Here's a list of things that I will think of in order to decide from test cases. For example, the novelty of the feature. So if a feature is new, obviously I have to put more attention to it. the priority of the test case, right? The priority of the feature. Sometimes we can also give priority to some features over another ones because maybe there's a feature that basically makes money for the company, so we want to put that feature and test it inside out, or maybe about the severity of the risk of the test cases or the feature as well, right? If something is meant to break and cause a lot of trauma to the users, we obviously want to test that thing inside out. The number of bugs that it was found by that test, or the number of times that it has failed where it actually was a bug related to it. The more it fails related to a bug, the more we want to run it. However, if it's failing because it's bad maintained, maybe we don't want to run it, right? And there's many other variables that we can take into account, like the ratio run versus fail, the direction of the execution, the ratio of the execution, and the last time of execution. It's not ratio. there's an extra N there. Forget about that. So basically, that is what we are looking forward to automate, right? We are trying to figure out which variables are we using in order to decide should we run this or should we don't run them. Funny enough, some of these variables are not recorded anymore. Some people just maybe mention them or maybe tag some of the issues, but then we don't tag it as much as we used to back at the time with different systems that we had into place. So sometimes it's difficult to find out all this information, and this is super, super important if we're dealing with AI. It's all about data. So I will be repeating that later on. Just wanted to give you a bit of context first. Right, so once we have all the variables, what we want to do is what is called rules-based system. So we want to create a series of rules, right? So if the test case have a high priority, if it has high risk, if it has if it's very new, we definitely want to run that test case. We definitely want to create it. But maybe if it is being old and maybe it has very low priority, and maybe that one we don't want to run it anymore. So we have to figure out the relationship between those variables and put them into a series of rules, right? In order to implement some automation on top of that. So in this case, we also talk about how the rules are high priority, low priority, but obviously what is high priority for me may not be high priority for someone else, right? And that is what is called fuzzy, right? It means that things are not the same value exactly per all of the experts. So if I were to do what I did before and ask in the chat, if I were to ask you guys that are experts and every other experts that are out there about quality, which ones of the test cases will be considered high priority, exactly which number or which percentage of a test case will be high, I may find that this lands in some sort of, the function will land in some sort of, in this case, curve, right? So we are going to define things with percentages and probabilities, and we'll try to figure out what function they will be following. In this case, I have a function that is this is called a trapezoid function. And in this case, I made it up. Basically, is what I thought it will be looking like if I were to put this into a function. But obviously, it will be much better if I get the information from a lot of experts and I target the points and I figure which sort of function it follows. It could be a triangle, a Gaussian bell, it could be many other functions, right? In this case, I'm saying here that for me, something that is a low priority, it will be between 0 and 20%. It will be definitely a low priority. And if we follow all the way until 40, it will be decreasing low priority. So something that lands here, it could be low priority or it could be medium priority. I'm not quite sure, right? So it's all about creating those functions, and the medium priority is everything that lands here. So be very mindful of these points down here, because I'm going to talk about them in the demo that I'm doing. So 20, then 40, 60, and 80 for medium. And for high, 60 to 80 is not sure how much high it will be, but from 80 to 100 is definitely going to be a high priority. And I have something similar for a yes or no. In this case, for example, if something is new or if a test case is failing, it's a bit more clear, right? It's either yes or no, but sometimes terms of is new or is passing. I mean, maybe not so much for is passing, but is passing could be more fixed, right? But maybe something that is new. What is new is a day ago, is an hour ago. So the word new is not the same depending on the context, depending on the person, and depending on the expert that we ask. And that's why it would also follow some sort of function. In this case, I'm using just a triangular function because it's a bit more, it's either yes or no. There's nothing that is going to be intertwined. It's either one thing or another, right? And we do exactly the same. So again, look at below, it's just breaking into 50. And so that's our first step. So first step, just to recap, understanding what you are doing, what do you want to automate, finding out the variables that will bring your decision up and down, and understanding some rules with those variables, and define something that is fuzzy, something that is not super clear, into something that the computer can understand, so percentages and numbers and mathematical figures. So now I'm going to see the demo of that system, of the rule-based system. So just 1 second. And I'm going to make it a bit bigger so you guys can see. Hopefully you guys can see. So in this case, I'm using a function from the scikit library in Python. In my blog, I have this in C#. So if you're interested, you can see the code in C# as well, using a different function. And I'm also using NumPy. NumPy is really known in Python to deal with numbers. In this case, is just to get a range of number that goes from 0 to 101. So basically, 0 to 100, sorry. Basically, that's why I say 101, because otherwise it will go 1 to 100. And I'm going to be defining the labels for all the variables that I'm checking, right? So the risk, the priority, if it's new, and if it's has been passed before, right? This is just an example. Of course, this should be taken, if we were to bring it forwards, we have to make a good decision on all of that. And they're called antecedents because it's what is coming before the rule. So the rule is, if you have the high priority, if you have high risk, then you should execute. That's why should execute is called consequence. And sorry for showing a video, by the way. I'm just don't trust in live demos because I had bad experiences. So I hope you're fine with that. This is totally my code. I write it. So don't worry about that. And now we define what's low, medium, and high. So as I showed before in the graph, and the numbers that I mentioned that are very important, we are showing here a trapezoid function, and we're saying exactly what of the points are building the trapezoid for us. And saying the universe, it means take the antecedent that we defined before, right? So we do the same for the priority. And in this case, I'm using the same values for high priority and high risk. Again, if we bring it to the expert, they may vary, we don't know. But I just, to simplify things, I'm using exactly the same. So I'm defining the same things for the risk. And I'm going to define now the same for is new and is passing, and the same for should execute. The reason that I defined that for should execute is because this is called fuzzifying, but you can also defuzzify something, right? So if you get a percentage, you bring the percentage and the computer should tell you if it's a yes or a no. And this only has 3 points because it's a triangle, so it's a bit easier to define. And again, I repeat the same for the is passing and for the should execute. And the next step is to create my rules, right? I'm only going to create 6 rules here, and they may not make a lot of sense for you. And they're just, again, as an example, right? In this case, if the risk is low, we should not execute. what I found when I was creating the rules is that it's super difficult to figure out rules that are don't execute. Most of the rules that I could think of were like, yes, it should execute. But we also have to define the no ones so the system is able to decide. And in this case, I'm creating a rule for high risk as a high priority, then we should execute medium priority, and if passing, then maybe we should not execute. We should execute, sorry, and so on and so forth. Then we add those rules to our control system. This is just adding them together. And then we add the control system simulator, which is basically how we call the system that we're going to run. And we're just going to give them the inputs. What are the inputs? The inputs are my test cases. In here, I'm doing this on my same on the same code. Let me take this away from you. But basically, this will be a test case that have 20 on priority, 20 on risk, 90 on is new, so it's a very new test case, and is passing not, right? So in this case, that's my test case. I'm creating it as I say in the same code. Ideally, you should get some maybe database where you pull those from, and then you can organize by the output, and then you can even check the times that it take and just run the ones that will take. If you say I have half an hour to decide, you can just take the ones that are higher, should execute within half an hour. And I'm just printing here if it should execute or not. And this view is so I can see the graph. So in here, now I have a couple of issues. First of all, I have a typo here. It says SK Fuzzy. Again, SK is from Scikit, which is a really good library in Python for machine learning and artificial intelligence relating things. And in here is no simulator, it's just Simu. And that's my 49.0%, which lands around this area. For this test case, basically, we should not execute, but if we have time, maybe we should. So it's not very secure. Of course, my system is, as I say, I mentioned a lot of we should execute, so it will be tending always to the should execute. And for this second case, I switched to having 90 priority, 90 is risk, 10 is new, and 90 is passing, right? So with those data for the test case, then I get an 80-some%, which lands over here. And as you can see, this is highlighted. So in this case, we should execute this. But that's sort of how it works for this system. Again, the thing about this is that you have to give them all the rules, and you can make mistakes giving those rules, right? I see a question there, but I think I'm going to get the question at the very end. So I hope I can answer, and if not, I'll ping you in a bit. And let's continue with the slides. So the points about the, sorry, there we go. I was still in Zoom. The points about the fuzzy logic and the rule-based system is that you need the experts. In my example, I'm making the system too safe, which means that I need to, maybe we need to analyze more variables, and it means that it will say yes to execute all the test cases, but obviously we need to be able to divide it. So as we define it, it's going to behave. The rules are definitely not easy to define. So for example, shall we run all the test cases with risk high, even if the test case is really old? Change rules if the app changes. So when the app changes, maybe the rules also have to change within, or even when someone changes, the expert that is giving saying what percentage of priority is coming up, right? So then we need to check the system again. Fuzzy means that it's not straightforward, so it will have fuzzy results. And there may be some relationship that you are not aware of, and we'll talk about it in a bit. So the problem here basically is that the things are not inferred. Inferred is like decided, right? Is that we have to give them all the steps. And that's why I thought we could use something better, right? So I thought about using artificial intelligence. So again, let me just define what's artificial intelligence, and then I will tell you if what we think is artificial intelligence or not. So the definition that usually you find is that artificial intelligence gives the computers the ability to learn without being explicitly programmed. And that's by Arthur Samuels on 1959. So because of this definition, a lot of people would say that this rule-based system is not really so intelligent because we are explicitly programming those rules, right? So there are kind of people that think that that is artificial intelligence. There are people that think that is not. So let's try to make the system more intelligent, right? Another definition that I really love about artificial intelligence is that of Luger and Stubblefield in 1993, which says that it's the branch of the computer science that is concerned with the automation of intelligent behavior. Automation, right? That's what we do. So I absolutely love that. That means that we should be looking into artificial intelligence. So if you don't know about it, it's coming here to stay. So you should definitely learn more about this. It's a big area, and we could use it for many play areas in testing. We could use it about in other areas. There's people that dedicate their life to their careers to this particular area. So it's really, really big. So I'm gonna just simplify it as much as I can, and let's keep going. So let's say why artificial intelligence, right? I've kind of mentioned it before through the slides, but I'm just going to be a bit more specific about it. So in this case, imagine that we have a supermarket. This is a very common example. If you learn artificial intelligence, you will see that. If you have a supermarket and they want to increase their sales on beer, what would you put next to the beers basically in order to get more sales? And we could think about maybe chips, right, or maybe pizza, but they run this into an artificial intelligence system and figure out dippers or nappies, depending on where in the world you are, will increase the beer's sales for this particular supermarket. And they put it into practice and it worked. So there's a lot of things that artificial intelligence can predict that we wouldn't think about them as humans. There's many other examples, a supermarket predicting pregnancies of people by their shopping habits, even who is a better home insured based on their cooking habits. So there's so many things that they can predict that we could not. So that's what we want. We want something like, for example, the priority of the test case could be covered by the priority of the feature. So there's many things that we cannot really tell. For our case, for example, maybe if a test case is new, we shouldn't really execute it because we covered it so much in unit tests. I don't know, it could happen. So it will be very interesting for us to tell. So if we want to build an artificial intelligence system, the first thing that we need to know is to clean their variables, right? As I said before, the priority of the test case could be covered by the priority of the feature, so maybe we don't need to look into them both. And the times that the tests have failed could be also covered because maybe the test is wrong, so maybe we should not execute it based on that. And if a feature is new, it could be covered by the unit test, as I mentioned before. So we really need to clean up the features, that the variables. That's the first thing that we need to do. And the next thing is that we need to get a training set. So basically, we need to understand the system, so get a lot of data and train our system. Obviously, we don't say you're wrong or right. Like, I don't know, we don't give we don't give like tips to the system to say you're good tricks, right? What we do is that we can learn routinely or iteratively. We can learn by instructions, or we can learn by analogy. So we have a goal, we create some theory around that, we apply a function, and we see how it lands in the system, if it's nearer to the goal that we set or not. That's sort of the way that it works. Very, very simplified again. So if we show this to a system and we say, this is a cat, and we show this and we say, this is a dog, and again a cat, and a dog, and another cat, at some point, after doing this many times with many pictures, there will be a moment that we show this to the system, and the system will say, well, that's a cat. And we show this little cute guy here, and the system will say, that's a dog, right? And then we show this to the system, and maybe the system doesn't know about this one. So funny story, there is a myth that Chihuahuas, the first time they being appear or someone saw them, they thought they were rats instead of dogs. It's a myth. Again, Chihuahuas are a breed that is being bred by many years, so it's not possible. So it's really, really important that you have the right training system in order for don't bring your bias into the system, right? Because you can transfer it to the system. And there's a good book that I can recommend that is called Hello World, and the full name is How to Be Human in the Age of the Machine by Hannah Fried, and they give a similar example about wolves and husky. And the system was able to identify husky from dogs, and they realized that in all the pictures that they give from the wolves, there was snow in the picture. So really the system was telling if there was snow or not snow. So when they put the husky with snow in the background, the system will think it's a wolf. But then again, how will we know if it's a wolf or not, right? It's about understanding us in order to transfer it to the system. So if you want to do this with machine learning, there's many algorithms, there's decision trees, inference rule, nearest neighbors, neural network, genetic algorithm, random forest. In this case, I think we're dealing with classification for this particular example, but there's so many algorithms. People usually have 2 or 3 that they put up together. They figure out which one works better for the system. And for example, the easier classification algorithm that there is the K nearest neighbors. And I used this one in my final year project really long years ago, and to decide for number plate. And this was used just for kind of highlighting the objects in an image, right? So to get the pixels more separated. So we'll decide what sort of pixels were near myself, and I will get the color of the more common pixel there. In that case, for the image, it will bring the contrast higher. So this is just an example of things you can do with machine learning. There's so many up there, and I hope you get inspiration now to do your own. So what are my conclusions about the machine learning? So it's really good for things that you may not have thought of. If you don't have any algorithms before, or those algorithms are way too complex, or they have bad results, then definitely you should go and look into machine learning algorithm. You need training data first. So you need data that is easy to gather and is easy to save. So maybe you have it in a database or in a safe location, all protected, obviously. And again, if I were to be training this every time I get a new test case and I need to retrain the system over and over again, that will take way longer than manually setting the rules, right? So you need to really be careful about, is this the correct thing for my system? And then if the data changes, it could lose effectiveness because you've trained it with a particular set of data. So for example, coming back to the husky and wolf example, if I get a new set of huskies that have snow in my picture, then the algorithm is not valid anymore, even though it was working so well, right? So we have to be careful about those kind of changes as well, and always keep an eye in our AIs. And again, be careful with your bias. In AI is super, super important. If you're testing an application that is working on AI, careful with bias always. So if I'm not using AI, what could I use? So as I say, there's a set of strategies that we can have into account in order to get this done. You can parallelize the test cases, right? You can run them in different servers. And then even if you have 1 million test cases, they're going to run much faster than if you were running one after the other, obviously. You can focus on the latest features and then do an end-to-end in a separate turn-off server. So sort of the things that they do with the canary of the red and black systems, right? That you get different servers on and off, and you do all the tests that you need in the server. And if everything is go, then you can put the users to that server and turn off the servers that currently were serving users. You can use load hours. This is what happened to me in the company I mentioned before. Don't do this. It's really painful. Waking up at 3 a.m. to do a sign-off of a feature is not good for anyone in the team. It's not good for the morale or anything. There's other strategies that are much better. I just want to mention it because I know some people may be doing it. So you see that there's better alternatives as well. You can use the rule-based system that I proposed before, set up your own rules, set up the things that are better for you, check your variables, and you can also have a manual decision. So that will be also very, very time-consuming. But if you prefer doing that than any of that, is really up to you. And that's the end of my presentation. I hope you enjoyed that. And I hope I wasn't going too fast through it. I think now we have some questions, right?
Yes, we can get right into questions. Folks, if you have questions, please drop them in the chat. We will start addressing questions now. So we have a question. I think you mentioned one of the resources. If there are any other, if you're new to using AI with testing and automation, are there any other resources that you would recommend on starting with?
Yeah, I can send you a list of resources. So for learning AI, there are some things for automation or for testing, but definitely go and check a course on AI. There's free courses even from the Stanford University. It's really one good one. Excuse me.
Awesome. We will, guys. We will send out that list. So stay tuned for that list.
Thank you. So there's a really good one for NG for in the Stanford University. Is a good one. There's course in Coursera. There's many masters you can do. So and there's a lot of free online information in the blogs. You can go to my blog to see the test case decision. You can see the code in there. You can even copy and see if it works for you. And definitely, if you do want to check that and you try that, let me know, because I'll find it super interesting if you like it.
Awesome. Thanks, Noemí. There's a question on using trends, bug trends to prioritize tests. Can you maybe talk about any experiences in factoring in bug classification?
Can you repeat the question? Sorry.
So the question says, any experiences in factoring in bug classification using trends, trends for bugs to essentially using bug trends to prioritize which tests to run?
Yeah, so I know there is a tool which is called test project. I forgot the name. Again, I can link it back with the resources if you want. And this one, you can see what I think it takes the information on the description and the title of your test cases or on your books. And then you can figure out what sort of things are failing more frequently. So you can prioritize things based on that as well. And I find that super, super interesting. And definitely, if I were to work in this further, I would look into text recognition as well. Does that answer the question?
Awesome. We have a question on the goal of AI. What's the goal for AI? Just a classification to execute or not a test? How would you create a training set? You spend a lot of times testing. Do you spend a lot of time manually, or do you have a smarter way to generate that training set?
Yeah, so basically, the goal of this AI will be to decide a test case. Could be execute or not, or could be other things. Could be to automate it, for example, right? So how do you create the training set? So what you do is that you go into your tools when you have all the test cases defined, right? And you bring up data out of that tool. So you need to do that bit of automation first, and then you put it, say, in a file, in a sort of an Excel file, and then you can get information out of there. You don't need to do it manually. You can do that definitely by taking them from your database. Of course, your database was created manually by someone, but I don't think you can automatically create test cases or define test cases as yet. But hey, it's a good idea. If you want to go ahead and do that, please let me know, because I would be super interested in see how you did that.
We have a question on, do you apply rules based on, do you buy rules-based testing on PR reviews?
I can't talk about work, so I can't answer that, but you could if you want.
Sure. Then we have a question about how you got started with AI. Is this something that you started because of the state of things?
No, so again, AI, even though it sounds like the latest trend, AI has been there for many years. And I got started in it in the university. So when I was studying my computer science degree, I started on things with AI, and I learned a lot of things related to AI. And as I mentioned before, it has changed so much, because before we were more focused on this sort of rule-based system, and everyone was looking into logic and how to define things and how people think and how people will like decide between things. But then the way the computers are evolving, they're getting faster, and then you have the cloud in which you can run things in different servers and computers all over the world. And also you get a lot of data coming from the internet, a lot of data. All of that enable the AI part of machine learning and deep learning, and now everyone is looking into that side. So one of the things that I wanted to present today is an option, right? So if you want to get into AI, if you want to do some stuff with AI, you don't necessarily have to go heads on the deep learning, because it may not be the good thing for you or the best thing for you in this case.
We have a question on how do you mark features as having recently changed and connect that to the logic which changes the AI rule set to the corresponding appropriate tests.
Could you repeat that, please?
How do you mark features as recently changed?
Mm-hmm.
Is there a way to connect that to the logic?
Yeah, so you can connect them by, well, recently changed feature or recently created, because if it's recently created, is basically you have a feature definition, so it's going to come there. If there's something that is changing in the feature, you can also track that system. So it's all depending on where you come from. There's so many different ways that we track features that it would be very difficult for me to go and tell you every one of them how to do it. But if you have issues with them, feel free of pinging me. I'm super happy when someone pings me and asks me questions all the time. I like helping people. It's the reason why I'm here. I wouldn't be here otherwise, believe me. And then again, if you have the links to your code, you can see what part of the code is being changed, and you can use that as well for your tests.
Awesome. We have a question. Can AI be applied to tests on JavaScript as well, or is it just limited to Python?
No, you can use it in many different places. JavaScript, I haven't played with JavaScript and artificial intelligence as yet, but usually in artificial intelligence lot more kind of on the back end. So I don't know if Node, maybe Node will have something related to that. I'm not sure. I have done it with C#, as I mentioned. It's in my blog. You can go and look into the code. And I've tried Python as well, because there's a lot of really good libraries, Scikit and TensorFlow, for artificial intelligence in Python. So that's a really good tool that we have there. I'm not particularly familiar with JavaScript, but there may be, I don't know.
Awesome. So that is time for time we have for questions. Noemí, thank you so much for coming on board, sharing your knowledge. Love how you explained everything and broke everything down. Very insightful session. I think we missed one question on SOA structures. If you can address that in the chat. Okay. But thank you so much for coming on board. We enjoyed the session. Some great comments in the chat.
Thank you, guys.
Thanks, Noemí. Give it up for Noemí.